happy morning to all. Happy morning. Okay. Dear children, whenever you are writing the assignment, you have to write your name, okay, and which section you are studying. That also I am expecting, okay. Don't forget to write your name, okay. So anyhow, today also all of you should write the assignment. Today our selected portion, learning objectives, to learn about the structure of carbon compounds, that is carbon monoxide, carbon dioxide, ozone, and one more compound, sulfur dioxide structures. That means the electronic dot structure of this compound. How can you draw the dot structure of these compounds? First of all, you must know the atomic number of the element. For example, carbon atomic number 8, am I right? Sorry, carbon atomic number 6, oxygen atomic number 8, am I right? So carbon, first shell how much electron occupied? 2 electrons. Second shell, 4 electrons. So what is the outermost electron? 4. Oxygen, first shell 2 electrons. Second shell 6 electrons. So the outermost is 6 electrons. The valence we are saying. So how we draw the structure means, first you have to count the number of electron present in the outermost shell. For example, carbon monoxide means 4 outermost electron for carbon, so 4 plus 6 electron for oxygen. So 4 plus 6 is equal to 10 electrons. Am I right? By means we are counting this electron and we are mentioning the electron dot structure. So one by one we can be discussed. This also take the note of it. We can be draw the structure of carbon monoxide, carbon dioxide, etc. Okay. Dear children, today our learning objectives to learn about the dot structure of carbon oxide, ozone, and sulfur dioxide. Carbon oxide means carbon monoxide and carbon dioxide, and about the ozone and sulfur dioxide. The first one, we shall take one carbon monoxide. Carbon monoxide. What is the formula for carbon monoxide means? CO, carbon oxide, carbon monoxide. Clear? These are very important for the 12th grade. I think that more than 10 electron dot structure having, especially carbon dioxide is a very important. First we can start from carbon monoxide. Okay? First you have to say the each element atomic number. The atomic number of carbon is equal to 6. As per the first shell, we can be accommodate 2 electron. Second shell is the 4 electron. The 4 electron is called as the valence electron. Am I right? Second one about the oxygen. The atomic number of oxygen is equal to 8. The first shell we can be accommodate 2 electron. The second shell we can be accommodate 6 electrons. Am I right? So anyhow, for the carbon monoxide, the total number of valence electron is 4 plus 6 is equal to 10 electrons. How much electrons? 10 electrons. Okay. So, here having only 2 elements. So, I am giving one single bond between carbon and oxygen. How much element? 2 elements. Okay, here the one single bond denotes that they are having how much electron? 2 electron, am I right? So one single bond that is denote that it have how much electrons? 2 electrons. That the electrons are shared between one from carbon and one from oxygen, am I right? So 2 electrons is over out of 10. What is the remaining electrons? Okay, that is 10 minus 2. We can get remaining is 8 electrons. Am I right? So here I am starting with oxygen. Okay, oxygen. Out of 8 electron, I am accommodated here 6 electron. 1, 2, 3, 4, 5, 6. Okay. So 8 minus 6 is about remaining 2. The 2 will be accommodated here. Okay. So total 10 electrons. Am I right? Is that no? How much electrons? The remaining outermost shell 10 electrons. 10 electron means here already 2 over. Am I right? Remaining 8. 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, already 2 over. Then 8 plus 2, 10 electrons. Okay. This is a dot structure. Here, all of you know that one element is present. For example, oxygen is present here. It is here also 2 electron, here also 2 electron, here also 2 electron, here also 2 electron. Total 8 electrons comes means it is attain the inert normal case. Am I right? It attain the inert normal case. Electronic configuration. Okay. Anyhow, here what is the aim here means first we have to find the charge of an element. Okay, charge. We have to find the charge. Before that, it exhibits in a canonical form. That means having another more structure also having. For example, suppose I am taking these electrons, these 2 electrons to here means here now it having a single bond. Suppose the 2 electrons come here means it become what? A double bond. Am I right? Carbon, these 2 electrons come here means carbon, oxygen double bond. So here already having 6 electron, 2 electrons goes there, then remaining how much electron? 4 electrons. So 1, 2, 3, 4. Is that no? Carbon also already having 2 electrons. 1, 2. Okay. Then one more form I am ready. Again, these electrons, 2 electrons to join here. So the double bonds becomes a triple bond. Am I right? The double bond becomes triple bonds. So carbon, triple bond, oxygen. So remaining 2 electrons. Is that no? 2 electrons. 2 electrons. So listen all of you. First we have to find the charge. How we can find the charge means have 2 methods having. First method I am saying that first we have to divide like here and count the valence electrons. Okay, valence electron. For oxygen atom, the valence electron is 6. Am I right? And about the carbon atom, okay, the carbon electron also, carbon atom, the valence electron is 4. Is that no? For oxygen, the valence electron is 6. For carbon, the valence electron is 4. Now we can count them. Okay. This is the lone pair of electron. 1, 2, 3, 4, 5, 6. 3 pairs of lone pair of electron. But here having a bond between carbon and oxygen. They have a bond between carbon and oxygen. This also mutual sharing of electron. That we are saying the covalent bond. Right? So there is sharing of electron also. This electrons goes to oxygen and this electron goes to carbon. So we are counting here 1, 2, 3, 4, 5, 6. Here 1 plus so 7. Am I right? 7 electron having. Already the valence electron is 6. So excess electron. So we are saying that it's a minus charge. Minus, negative. Okay? Outermost having 6 electron, but here having 7 electrons. So 7 electron means we are getting minus extra electron, additional electron. What about the carbon? Carbon I told that here valence electron is 4, but here having 1, 2, 3. Shortage of electrons. So we are giving what? Plus. Okay? Plus charge. Plus charge, minus charge. Next we can define another one. Here carbon monoxide can be found here. Find out how much electron? 1, 2, 3, 4. Here also electron. 5, 6. Am I right? How much electron total here having? 1, 2, 3, 4, 5, 6. So valence electron is 6. So there is no, you can be say 0 like that. Okay. One more. Here carbon can be find out that 1, 2, 3, 4. Am I right? So outermost shell having 4 electron. There is no extra electrons, or no shortage of electrons. So we can give 0. So no. The next show. Next here. Here having, we are dividing like that. So no. 1, 2, 3, 4, 5. But here how much electron? 6 electron. There is a shortage of electron. So we are giving plus for oxygen. Am I right? Plus for oxygen. What about the carbon? Carbon having 4 electrons. Here I am going to count 1, 2, 3, 4, 5 electrons. So excess electron. So negative charge. Which are negative charge. This is the one method. One method of finding. And another one more method also having. By using the formula. Okay. By using the formula. First, what is about the formula? Valence electron minus lone pair of electrons valence electron minus lone pair of electron minus bond pair divided by 2. Okay, this is our formula. Okay, formula. Okay, can you understand here, children? What is the formula here? Valence electron minus lone pair of electron minus bond pair divided by 2. Just we are calculating for this carbon monoxide only. Okay, we cannot calculate the carbon dioxide because insufficient of time. We have to take return practice. Anyhow, first one we can be find from carbon. Okay, we can be take carbon element. Okay, what is the carbon element valence electron? What is the valence electron? 4. 4 minus lone pair of electron. Carbon how much here? Lone pair of electron 2. 2 minus carbon have only one lone pair of electrons. Okay, pairs. Here we are writing 2 electrons minus bond pair. Listen, how much bond pair here? 1, 1. Am I right? 1 plus 1. That is 2 divided by 2. So that is equal to 4 minus 2. Okay, 4 minus 2, 1. Is that no? Then 4 minus 2, 2 minus 1. So what's the answer? Plus 1. So this is the charge, plus charge. Okay, for carbon. What the case of oxygen? We can find the oxygen. Oxygen. What is the valence electron of oxygen? Valence electron how much? 6 minus. How much lone pair electron carrying oxygen? Lone pair of electron? 1, 2, 3, 4, 5, 6. 6 electron. Am I right? 6 minus. How much bond pair? Only one bond pair. That is 2 electrons. 2 as per the formula. 2. Yes or no? So we can written as 6 minus 6 minus 1. So 6 minus 6 is equal to 0. 0 minus 1. So what's charge? Minus negative. Negative 1 is the charge. Like that. This method also we can be right. Okay. For the second structure, okay, first structure is over. Then we can be find out the second structure. Okay, the second structure for the carbon. First we can be take the carbon. Okay, carbon. What is the valence electron of carbon? We know that one. That is a 4. 4 minus lone pair of electrons of carbon. How much lone pair of electrons are we? 2 lone pair of electrons. So we are giving 2 minus bond pair. How much bond pair is there? 2. That is, you can write 4 by 2. Am I right? So what is the formula? It's a formula. How can you substitute here? 4 minus 2 minus 2. It is 2 minus 2 equal to 0. So this carbon becomes the charge is 0 neutral. Am I right? Next one. What is about the oxygen? Oxygen, what is the outermost shell? The valence electron? 6. Let's say 6 minus, as per the lone pair of electron, how much? Here lone pair of electron? 1, 2, 3, 4. 4 minus. Then about the bond pair, how much? 4 by 2. 4 by 2. Bond pair means here having 2 bond, double bond. So 4 by 2. So how can you substitute here? 6 minus 4 minus 2. So 6 minus 4, 2 minus 2 equal to 0. Here also 0. Okay. Next about the last structure, carbon triple bond. Okay, carbon triple bond oxygen. What's the structure? Valence electron of carbon. How much valence electron of carbon? 4. 4 minus lone pair of carbon. How much here? 2 minus bond pair is 3. That is 6 by 2. Okay. So 4 minus 2 minus 3. Yes or no? So can you say what is the answer here? 4 minus 2 is equal to 2 minus 3. So what's the charge here? Minus 1. So here the negative charge. Okay. What's the carbon charge here? The negative charge. Negative. Okay. Don't forget that. Next one. What about the oxygen? How can you find out the oxygen? This is for carbon. And next about oxygen. Okay. What is the valence electron of oxygen? Valence electron of oxygen. That's 6. The lone pair of electron here oxygen 2 minus 2 minus bond pair. That is here I have triple bond. So we can written as 6 by 2. Am I right? So 6 by 2 minus 3. 4 minus 3 equal to 4 minus 3 is equal to plus 1. So what's the charge here? Plus is the charge. Okay, this is another method. Anyhow, we can use the short form. Okay, before I told that one, we can use the short form. Okay. Next, we can learn about that. The structure of electron dot structure of carbon dioxide. Carbon dioxide. Electron dot structure of carbon dioxide. CO2. Yes or no? CO2. It's not a few. For CO2, first you have to find out the atomic number of carbon. What is the atomic number of carbon here? Atomic number of carbon is 6, and also atomic number of oxygen is also 8. Am I right? So first you have to write that one. Carbon atomic number 6. The first shell we can be accommodated 2 electron. Second shell 4 electron. This is called as a valence electron. Next one, oxygen. Atomic number is 8. First shell we can be accommodated 2 electron. Second shell 6 electrons. So total the available electrons. Available electron is here having for carbon monoxide is 10. For carbon dioxide, how can you calculate means? Here having 1 carbon. So 4 plus the valence electron is 4. 2 oxygen. 1 oxygen is 6. So 2 oxygen is 2 into 6 equal to how much electron? 12 plus 4 equal to 16 electrons. So don't forget that the available electron for carbon dioxide is 16 electron. Actually, how much the requirement? Requirement means for the inert gas, for attaining the inert gas configuration. Suppose oxygen atom is like that means one side we have 2 electron, this side 2 electron, this side 2 electron, here also 2 electrons. So 8 electrons is required for the inert gas configuration. Am I right? 8 electrons. Like that we are multiplied here having 3 elements. 3 into 8 is equal to what is tell me? 24 electrons. How much electron? 24. So this out of 24 I am subtracting 16. Okay, 24 and 60, if you are subtract means we get the remaining 8 electrons. Am I right? How much electrons? 8 electrons. It's not a few. The 8 electrons shows that it contains 4 bonds. Am I right? That means one single bond means 2 electrons. Yes or no? So double bond means 4 electrons. Triple bond means 6 electrons. Am I right? Okay, then 8 electrons is one more bond. So how much bond is there? 4 bond. Yes or no? So for that we are dividing 8 divided by 2 is equal to 4. So 4 shows that it must contain how much bond? 4 bond. How much bond? 4 bond. So first we have to write like that. How much element is there? 3 elements. First I am writing oxygen. Next I am writing carbon. Next I am writing oxygen. Okay. Carbon is at the center. Both the two sides are the oxygen. How much electron? How much carry here? 4 bond. How much bond carry? 4 bond. Here having first I am filling the single bond. Then I am giving the triple bond because here having how much bond? 4 bond. 4 bond means how much electron needed? 8 electron. Don't forget that. 4 bond means 8 electron is needed. Okay. So out of 16 electrons, 8 electron is over. Yes or no? Available electron is 16. That is, the valence electron is 4. 4 plus 2 to 4 plus. There's the 2 oxygen is there. So 2 into 6 is equal to 12. 12 plus 4 is equal to 16 electron. Total, our hand having 16 electron. Out of the 16 electron, 8 electron is over as a bond. Am I right? 16 minus 8, the 4 bond is having. Remaining we have 8 electrons. Out of these 8 electrons, single bond we are having means it can be accommodated 6 electrons. Okay. Single bond having means how much electron accommodated? 6 electrons. That is 1, 2, 3, 4, 5, 6. Am I right? So we know that one. We need 8 electrons for the occurring inert gas configuration. Okay, so this is an 8 electrons. Am I right? 8 electrons. Okay, next. Here 8 electrons over 8, remaining 8 this bond becomes, then remaining having 8 more electrons. Out of 8, 6 electron over, then remaining 2 more electrons we are giving for this oxygen. Okay, total 16 electron. Don't forget that. Total 16 electron. This 16 electron and given a dot like that 1, 2, 3, 4, 5, 6, 7, 8, 8 over. Remaining 8 4 electron. That is 1, 2, 3, 4, 5, 6, 7, 8. Is or no? So 8 plus 8 is over. Is or no? Then we can find out the charge. How can we find the charge? I told that we have to separate the bond like that. Okay, here I am separating. Separate it here. Okay, separate. Now count the number of electrons. Okay, I told that valence electron of oxygen is 6. We can count that one. 1, 2, 3, 4, 5, 6. Here one more electrons. So excess electron. So we are giving which charge? Negative charge. Okay. And about the carbon. Okay, we can find out the carbon. Carbon outer valence electron is how much? 4 electrons. Am I right? So 1, 2, 3, 4 electrons having. So there is a no charge here. They say so. We can give no sign there. Next about the oxygen. This oxygen. Oxygen outermost how much electron? 6 electron. Here having 1, 2, 3, 4, 5. Out of 6 we have only 5. That's a shortage of electron. So we are giving plus charge. Okay? We are giving charge plus charge. Then another one more structure. Another one more structure. Okay. Suppose I am giving one electron like that. I am taking one electron. These 2 electrons. These 2 electrons goes to like a bond here. So what's the formula? What's the structure? Here single bond becomes double bond. Single bond becomes double bond. So we can written as oxygen. Here having single bond. This enter means we are getting double bond carbon, double bond oxygen. Am I right? Okay. Now we can be filled like that. Okay. How much electrons? Total available electron is 16. Available electron is 16. That means here 4 plus outermost shell carbon having 4 electron. 2 into 6, 12 plus 4, 16 electron. 16 electron, 8 electron is given as a bond like that. Am I right? Bond, that is 1, 2, 3, 4, 5, 6, 7, 8. Then the remaining 8 more electrons. So we can be filled. Single bond having means we are accommodating 6 electron. Double bond having means we can be accommodate 4 electrons. Okay. 1, 2, 3, 4. Okay. Next, here oxygen. 1, 2, 3, 4. So this can be here, can be here. Okay. So 8 plus 8, 16. Am I right? 8 plus 8, 16. Okay. Then we can be count number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 electrons here. I told that 8 electrons is needed. Okay. Here also 1, 2, 3, 4, 5, 6, 7, 8. Is that no? So 8 electrons also over. Then how can you find the charge? Okay, how can you find the charge? You have to separate like that. Now we find that no? Outermost shell, how much electron is having oxygen? 6. So 1, 2, 3, 4, 5, 6. Okay, there is 6 electrons, so they have no charge. What about the carbon? Carbon having outermost shell is 4 electrons. So 1, 2, 3, 4. Okay, so that is also correct. There is no charge. What about the last oxygen? 1, 2, 3, 4, 5, 6. This is also correct. There is no charge for this structure. Okay, this structure having no charge. This structure having first oxygen having negative charge, and this oxygen having the positive charge. Am I right? Next one. Next structure. Suppose I am giving this electrons to here. Here, this electron goes to the next one. Okay. So first here in single bond, second step double bond, second step triple bond. Am I right? Oxygen, carbon, oxygen. Okay, becomes triple bond. Which bond? Triple bond. Yes or no? So, then here having one lone pair of electron. This oxygen having suppose here also having double bond. This will be go out. Am I right? This will be go outside. So it becomes 6 electron. So no? So then how can you find the charge? First separate here. Try to separate. Before that we can be counting here. 1, 2, 3, 4, 5, 6, 7, 8. So total we had 8 electrons. Am I right? Here also 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons over. Is that no? So 8 plus 8, 16. Then we can define the charge. Find the charge. Okay. So oxygen having outermost 6 electron. Now how much electron having oxygen? 1, 2, 3, 4, 5 having. There is shortage of 1 electron. Shortage of 1 electron means what is the charge? Plus charge. Okay. Here we can define here 1, 2, 3, 4, 5, 6, 7 electron having. Excess electron having. So the charge is negative. Like that, this carbon dioxide is also over. Okay. Can you understand? Next we can find out the structure of ozone. Can you say what is the formula for ozone? Oxygen formula is O2. And we are adding one more oxygen, so becomes O3. Is that no? Structure of electronic dot structure of ozone. oxygen, okay, O3, ozone. How to draw the structure of ozone, okay. Atomic number of oxygen is equal to 8. That is, first cell we can be accommodate 2 electrons, second cell 6 electrons. So outermost having 6 electrons, here having 3 oxygen, 3 into 6 is equal to 18 electrons. This is the available electrons, okay. But actually, as per the inert gas configuration, one element having 8 electrons, one element needed 8 electrons. So 3 oxygen, 8 into 3 is equal to 24 electrons. Am I right? How much electron? 24 electron is must. But here having only 8 electrons. Yes or no? Here having how much electrons? Sorry, only 18 electrons. Here having how much electrons? 18 electrons. So we can be subtract that one. 24 minus 18. Remaining is 6 electrons. Yes or no? So 6 electrons shows that it can be gives 3 bond. Am I right? It can be gives 3 bond. That means 1 bond means it requires 2 electrons. Am I right? 2 bond means double bond means it needed 4 electrons. Triple bond means 3 bond means it needs 6 electrons. So 6 divided by 2 equal to 3. It shows that it contains 3 bond. Oxygen contains, ozone contains how much bond? 3 bond, 3 bond. Okay, so first one oxygen, another one oxygen, another one oxygen. Okay, yeah. One oxygen, one oxygen. How much bond is having? 3 bond. How much bond is having? 3 bond. First 1, 2, 3 bond. Clear? Can you draw? There is 3 having, so we are using 3 bond. So the available electron for ozone is how much electron? 18 electrons. This 18 electrons, 6 is over. 6 is over. 6 over means 1, 2, 3, 4, 5, 6 over. Am I right? 6 over. Remaining how much electron? 18 minus 6 is equal to 18 minus 6 is equal to remaining 12 electrons. Am I right? 12 electrons. We can be accommodate 12 electrons. 12 electron means first single bond having means we can be give 6 electrons. Single bond means 6 electrons. 1, 2, 3, 4, 5, 6. Okay. 6 over. Double bond means 4 electrons. 1, 2, 3, 4. 6 plus 4, 10 electrons. Remaining how much? 2 more electrons. We are giving 2 here. Okay, can you understand? Available electrons means here having 18 for ozone. The reason is the outermost having 6 electrons. 6 here having 3 element having 6 into 3 is equal to 18 electrons is the available. Needed, how much needed? As per the octet rule, 1 element having 8 electrons. Here having 3 element having 3 into 8, 24 electrons. But we have only 18 electrons. So how much electron shortage means 6 electron is shortage. Okay. Here making bond. Okay. Here we are now to making bond. That means 1 bond needed 2 electron. Okay. So we are divided by 2. We get the answer 3. 3 shows that the ozone having 3 bond. The 3 shows that ozone having how much bond? 3 bonds. Okay. Yeah. So no. Okay. 3 bonds. So here we are subtracting 18 minus 6 because already 3 bond over 6. The remaining is 12. 12 we are accommodate 6. Single bond means 6 electron. Double bond means 4 electrons. We are accounting like that. So 6 plus this 2 we get the 8 electrons. Am I right? 8 electrons. 8 electrons. Here also already 4 having. We are giving 4. So this also 8 electrons is over. Yes or no? So now how can you find the charge? How we can find the charge of this molecule? Okay. I told that excess having a negative charge, shortage having the positive charge. Yes or no? So please count the electron. Oxide having outermost having 6 electrons, but we can count that 1, 2, 3, 4, 5, 6, 7 electrons here. So excess having the charge is negative. Okay, here we can find that one. 1, 2, 3, 4, 5, 6. This is correct only. This is correct. 6 electron only having. What about this oxygen? 1, 2, 3, 4, 5 only having. So here is the negative positive charge. Okay. Okay. Here have excess electron having. So negative. Shortage of electron. So become positive. Okay. This is about the ozone. Then one more structure. We can be given another one more structure we can be given. And this bond comes to this side means, okay, here ozone double bond, okay, oxygen double bond, single bond, okay. The same process, single bond means how much electron? 1, 2, 3, 4, 5, 6 electron. Double bond means 4 electron. 1, 2, 3, 4. Okay. So 6 plus 4, 10. Remaining 2 more electrons we are giving like that. Then find the charge. Okay. Find the charge of the electrons. Okay. Sorry, find the charge of the molecule. Okay. Here. Break it. How much electron having? 1, 2, 3, 4, 5, 6, 7, 7 having. So excess electron we can give minus charge. Here having 1, 2, 3, 4, 5 shortage. So we are giving plus charge. Okay. This is about the ozone structure. Okay. Next about the sulfur dioxide. How can you draw the structure of sulfur dioxide? Which are the elements present in the sulfur dioxide? Which are the elements present in the sulfur dioxide? We can say that one. Sulfur dioxide. Sulfur and oxygen. 2 oxygen having. Am I right? Sulfur and 2 oxygen having. We can be simply draw like that. We know that atomic number of sulfur is equal to 16. 2, 8, 6. Oxygen is equal to 8. 2, 6. Am I right? So valence electron is 6. Okay. 6 into 3. Am I right? 6 into 3 is equal to 18 electrons. How much available? 18 electron is available. How much required? 24 electrons. Because 8 into 3 is equal to 24. 24 minus 80, we get 6 electrons. Okay. So remaining having 6. If you are dividing 6 by 2 is equal to 3. So we can make it a 3 bonds. Okay. So sulfur, oxygen, oxygen like that. If you are giving like that, sulfur, oxygen, not like that. Sulfur, oxygen, oxygen. Yes or no? So single bond having out of 18, 6 is over. 6 is over. Remaining we have 12 electron. Single bond having means 1, 2, 3, 4, 5, 6. Okay. Double bond having means 4 electron. 1, 2, 3, 4. So 6 plus 4, 10 over. Remaining 2 electrons. Am I right? Remaining 2 electrons. Yes or no? So we can find out the charge. What is about the charge? Yeah, charge. So here having 1, 2, 3, 4, 5, 6, 7 electron having. 7 electron means outermost only 6 only having. 7 electron for oxygen. 7 electron. Here having only 6 electrons. 7 means negative charge. Okay, because we are expecting only 6 electron on the valence electron. Here having 7 electron. So negative charge. What about the sulfur? Sulfur also outermost 6 electron. Here having 1, 2, 3, 4, 5 electron. So positive charge. One more structure. Another one form. Make it here, make it double bond. Here make it single bond. So oxygen, double bond, sulfur, oxygen. Am I right? So single bond means how much electron? 6 electron. Double bond means how much electron? 4 electrons. Okay, 4 electrons. Next, we can find the charge. Find the charge. How much electron is having? 1, 2, 3, 4, 5, 6. Here having one more electron. So 7 electron. 7 electron means here I have only 6. 7 electron means negative charge, excess electron. Okay, here how much electron? 1, 2, 3, 4, 5, 6. 6 electron having. There is no charge. What about this sulfur? 1, 2, 3, Here we have to face 2 more electrons, so 5 electrons, am I right? Because 12 electrons needed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so here we have 5 electron. 5 electron means here a shortage of electron, giving positive charge. Okay, like that. You have to take return practice. I hope that you can to write this question at least 2 structure, any 2 structure. Okay, any 2 structure you have to draw. Either maybe carbon dioxide or carbon monoxide or ozone or sulfur dioxide. Draw any 2 structure and kindly send to me. All of you know my number. Am I right? Please post your valuable answers. If you are learning day by day, all the days if you are learning now, it's very easy for drawing and writing the formula. Okay, so please don't forget that. And 4, 8, 9, 3, 4, 0, 1, 2, 0. Okay, don't forget that. Please write and send to me any 2 structure. Okay, thank you all of you. Thank you. Have a nice day.